This is Alyssa Poth recording Quideo number 4 for AP Statistics. So the basic question says a Census Bureau reports that households spend an average of 31% of their total spendings on housing. And then a homeowners association in Cleveland believes that this average is lower in their area. They interview a sample of 40 households in Cleveland metropolitan area to learn what percent of spending goes toward housing. Take mu to be the mean percent of spending devoted to housing among all Cleveland houses, and they want us to test the hypothesis, and they give us a standard deviation. So part A says what is the sampling distribution of the mean percent of X bar that the sample spends on housing if the null hypothesis is true. Sketch the density curve of the sampling distribution. So the first thing we need to do for part A is make sure that the sample size is both large enough and small enough. So first, they don't tell us that the distribution is normal, so we can just assume that the 40 houses that were chosen are random. And then we have to make sure it's large enough, so we do n times p, and we have to make sure it's greater than 10, and then qp is also greater than 10, which both are. And then we need to make sure it's small enough by doing 10 times n, and there are more than 400 U.S. adults that own houses in Cleveland, so it is small enough. Then it asks what the sampling distribution is, and we can basically do that by sketching a density curve. So we assume they give us two things: the null hypothesis, which is HO, and that's 31%, and the homeowners association is stating that the average is less than 31%. So assuming that the null hypothesis is correct, the distribution would look like this, with 31 in the middle, because that's what their claim is. And then we can calculate the standard deviation by doing the population standard deviation, which they give us is 9.6 in the problem, divided by the square root of n to give us 1.52. And then you just subtract or add either side, and I went out 3 standard deviations, and so that's what the density curve would look like. Part B says, suppose the study finds X bar to be 30.2% for the 40 households. Mark this point on your axis, and then suppose the study results in an X bar of 27.6, and to mark this point on your sketch. So, and then it says, referring to your sketch, explain in simple language why one result is good evidence that the average Cleveland spending house is less than 31%, where the other is not. So, as you can see, the same density curve, I marked 30.2 and 27.6. So, it asks us why one is good and one is not. So, 30.2 is not a very large evidence that the Cleveland house spending is less than 31%, because it's not even one standard deviation away from what the Census Bureau claimed. So that wouldn't be a good claim by the Home Builders Association. But then 27.6 is more than 2 standard deviations away, so that would be a better claim by the Home Builders Association. Part C says, shade the area under the curve that gives the p-value that results in X bar being 30.2%, and note that we are looking for evidence that spending is less than the null hypothesis states. So just like I explained in Part C, this is kind of what it's not a significant difference enough than what the null hypothesis is saying, but we can shade to the left of that value. So the advanced question says Pew Research in November 2011 polled a random sample of 799 U.S. teens about internet use. 49% of those teens reported that they have misrepresented their age online to find access to websites. So part A says find the margin of error for this poll if we want 95% confidence in our estimate of the percent of American teens who have misrepresented their age. So to do that, you basically use the margin of error equation, which is plus or minus z star square root of p success times q failure over n, which is sample size. And so they tell us that they want a 95% confidence interval, so they want the margin of error for 95% confidence. So we know that the z star is going to be 1.96, and then they give us the success, which is 0.49, and we just subtract that from 1 to find the failure, and then they give us the sample size of 799, and we know that the proportion will be 0.0347 above or below the 0.49 proportion for success. Part B says explain what the margin of error means in context. So basically what the margin of error is saying that we are 95% confident that the true mean of the teens that lie about their age is between 0.4553 and 0.5247, and we found that by just going above and below the mean of 0.49 with 0.0347, which is what we calculated the margin of error to be in Part A. Part C says if we only need to be 90% confident, will the margin of error be larger or smaller? Explain. So if we only need to be 95% confident, we basically use the same equation except a different z star, and with a smaller confidence, we will have a smaller z star. So basically the only thing that's changing is this number we're multiplying it by, and if we multiply it by a smaller number, we know that the margin of error is also going to be smaller. So the AP question gives us a random sample of 1,026 adults that were asked the following question: based on what you know about Social Security system today, what would you like Congress and the President to do during this next year? And the answer choices were completely overhaul the system, make some major changes, make some minor adjustments, leave the system how it is now, and some have no opinion. So for Part A, it says find a 95% confidence interval for the proportion of all United States adults who would respond, make some major changes to the question, give an interpretation of the confidence interval, and give an interpretation of the confidence level. So basically for Part A, we know that we need to perform the PANCE procedure. So for P, the parameter of interest, we state that X will represent the proportion of adults that will make major changes to the Social Security. And then for A are our assumptions. So the problem states that the 1,026 adults are chosen at random, and then to be small enough, N times P has to be greater than or equal to 10, and N times Q has to be greater than or equal to 10, and both those assumptions check out, so we know that the sample size is large enough. And then we do 1,026 times 10, and we know that there's more than 10,260 adults in the U.S., so we can state that the sample size is also small enough. And then for N, we name the test, and we know it's a z-interval test because there's only one thing that we're trying to find. There's only one X bar, and we have the P and Q for both. So then for Part T, we test this. So we have our equation that with X bar plus or minus the Z star times the square root of P, the success, times Q, the failure, over N, which is the sample size. So we given the X bar of 0.39, that's the percent that responded that they want major changes made, and then the Z star for a 95% confidence interval is 1.96, And then again, we multiply it by the square root of 0.39, which is the success, times the 0.61, which is the proportion of people that would not answer it as that they want major changes, and then we divide it by the population size, which would be 1,026, and we get the confidence interval to be the proportion of 0.3601 and 0.4198. And so S is basically a statement of what this means, and so we are of what the confidence interval means. So we can say that we are 95% confident that the true proportion of all U.S. citizens that would choose major changes needed is between 0.3601 and 0.4198. And then the second part of Part A asks us to interpret the confidence level. And so basically that means if we construct a bunch of different confidence intervals, 95% of them would include the true average of U.S. adults that want major changes. Part B says an advocate for leaving the system as it is now commented, based on this poll, only 39% of adults in the sample responded that they want some major changes made to the system, while 41 responded that they only want minor changes or no changes at all. Therefore, the system should not be changed. Explain why this statement is technically correct but misleading. So basically, this statement is misleading because they did not include the people that wanted to completely overhaul the system. They just included the people that wanted the major changes. So when you add the major changes and the people that want to overhaul the system, that comes to a total of 58% versus the 41% that just want minor changes or to leave the system how it is. So really more people would rather change it completely or overhaul it than to leave it the way it is.